Snap Judgment Live tour each and every day. Get tickets right now at snapjudgment.org. And did I mention the closer? James Judd is on the lineup. Brand new story. Jamie DeWolf, Don Reed, the hilarious Jen Colbert. It's gonna be crazy. And snappers, you're asking, so I'm telling you. Spooked 7 drops in October, and this time it is a blowout. The scariest, spookiest, true life stories you have ever heard. Subscribe to the podcast so you don't miss a minute and never, ever, ever, ever listen alone. Snap is produced by the team that keeps its beautiful, dark, twisted fantasies to itself, mostly. Except for the internet. Please give it up for the Uber producer, Mark Ristich. The dark and brooding Pat Mesiti-Miller. The twisted Anna Sussman. The beautiful David Kim. Eliza Fantastic Smith. Nancy Jesus Walks Lopez. Joe Late Registration Rosenberg. And Renzo Ain't Nothing But a Gold Digger Gorio. Leon Morimoto in Paris. Liz Power Mac. Adiza, not a college dropout Egan. Teo, do not decay. Jasmine Aguilera has her own fashion line, and here's the thing. This is not the news. No way is this the news. In fact, you could read every scrap of gossip about me and Kim Kardashian playing horseshoes at the back of Bubba's Barbecue Shack, and you would still not be as far away from the news as this is. But this is WNYC.
And support for KQED comes from European Sleepworks, offering mattresses and bedding made from natural materials and free of harmful chemicals. Its cotton, latex, and wool components are fully certified by one of the world's leading ecological testing facilities. Details online at sleepworks.com. The DeYoung Museum presenting Ed Ruscha and the Great American West, featuring works that celebrate the iconic character of the American West with Ruscha's evocative landscapes. Tickets available at deyoungmuseum.org/Ruscha. And we're giving you the weekend off from pledge drive interruptions, but that doesn't mean we don't need your support. You can call us now at 1-800-937-8850 or go online to kqed.org/donate. Good evening, I'm Steve Fox. You're listening to KQED FM 88.5 San Francisco and KQEI FM 89.3 North Highlands, Sacramento. It's now midnight.
Oh, wait, you're listening?
All right.
You're listening to Radio Lab.
Radio Lab.
From
WNYC.
See?
Yeah.
So maybe we start with patterns. We asked Steve Strogatz, mathematician we sometimes have on the program, can you remember the first time you got crazy for patterns?
That's an easy one for me because I had a kind of epiphany that is hard to summarize in words other than religious. And I myself am not religious, but I had a very uncanny experience as a high school freshman.
He was about 14 at the time, and he was sitting in math class.
And our teacher handed us a little toy pendulum that was retractable.
A pendulum is basically a string with a ball in the end. And the string is attached to something so that when you push the ball, it swings back and forth. Back and forth, like a clock. Well, this one was a little different because you could adjust the length of the string.
That is, you could, like an old telescope, you know, that the pirate stretches out a spyglass, click, 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 you could make it longer in discrete clicks. And then the teacher gave us a stopwatch and said, I want you to time how long it takes for this pendulum to swing back and forth 10 times. Okay, so I do the experiment. 10 swings. I record how many seconds it took. Then he says, now make the pendulum a little bit longer. 1 click longer. Click. Do it again.
And as you might expect, since now the string is longer, it takes a bit more time
to make the 10 swings. And I write down the number. Click. Do it again. Click. Do it again. Click. Do it again. And I do this 5 or 6 times, and it was really tedious, dutifully plotting the results on graph paper, which is what the experiment was really supposed to teach us, how to use graph paper.
So he's got his graph paper there, and he's made 2 axes. One is the time it takes to do the 10 swings. The other is the length of the string. And he's clicking, measuring, making a little dot between the axes. Click, measure, dot. Click, measure, dot. Click, measure, dot. Click, measure, dot. Soon the thing is filled with dots, and that is when he noticed something.
This spooky thing was happening, which is that the dots, they weren't on a straight line. They fell on a particular curve, and I noticed that this curve was a curve I had seen before because I had just learned about it in algebra class, and it's called a parabola. And this really gave me the creeps. I had a sort of feeling of the hairs on the back of my neck standing up because it was as if this inanimate thing, this pendulum, knew algebra. My 13-year-old mind couldn't understand that. How could this thing swinging back and forth know something about parabolas, or how could that be built in?
Then an even creepier thought occurred to him. Wait a second. This parabola on my paper, which is the same one as the math book, is also out in the world.
It's the shape that water makes coming out of a water fountain.
It's also the shape of, when you shoot a rocket into the sky and it slowly descends. It's that.
It was in that moment that I suddenly understood what people mean when they say there's a law of nature.
Do you remember what it was that made your hairs stand on end? Was it that you had peeked in and discovered a secret? Or that you just simply found the right answer?
Much closer to the first thing you said, that there was this sort of veil over reality, a hidden universe that you couldn't see unless you knew math. It really felt like being let into some sort of secret society. It's a very intimate, personal thing, this feeling of wonder. That's a cliche, but that's really what you feel in those moments. And that's why my hairs on the back of my neck stood up, because of a sense of living in an incomprehensible and beautiful universe. But partly comprehensible. That's the beauty of it. I mean, if you're a lobster, you don't have this thought, right? A lobster doesn't get to think about the laws of nature. And so I've often thought to myself that it's a blessing that we live in a certain window of intelligence, that if we were infinitely smart, godlike, we'd have such powerful brains, we could see every implication of everything. So math wouldn't be fun for a being that's too smart. And of course, for the lobster that's not smart enough, math is no fun for them either. It's in this intermediate window where math and science become something to rejoice in.
Today's program is about a kind of search. A search for order,
For patterns,
hidden truth. And it's about the scientists who go out looking for those things and sometimes find them.
Oh, what's that? And sometimes don't.
Oh, I was crushed.
Humiliated. I felt stupid.
The question is, what makes these people tick? And we're calling this show,
Why do I love the fly that's eating my brain?
that'll make sense later. I'm Jad Abumrad.
I'm Robert Cole.
This is Radio Lab. Okay, you ready?
Yeah.
Off we go.
I think there's always been a desire to somehow categorize and classify the world around us.
Remember it? And when you were in, I don't know when it would be, like in 8th grade, when the teacher comes in general science and he pulls down the periodic table of elements.
Oh, yeah,
that?
sure. I mean, that was one of the first times where I was like, yeah, I don't want to be a scientist. It's not for me.
But for kids who love this kind of thing, take Oliver Sacks, for example.
Yeah, you should come in. I should come in? Okay.
Yeah, so a couple of years ago, we had went to talk to Oliver Sacks about something. And for some reason, we ended up in his bathroom.
I tend to read a little bit in the toilet.
Maybe to look at a book or something?
He seems to have facts and figures in his as well.
There's a lot of us in there.
Sorry.
And that's when we noticed.
You have the periodic chart in the bathroom.
In every bathroom.
But he had a periodic table of the elements on the wall in the bathroom.
We thought, wow, how funny. Periodic table in the bathroom. But then he said, well, if you go out into the couch, you'll see
Table cushions.
some cushions embroidered with a periodic table. And then he took us to his bedroom,
Although I don't usually take people into my bedroom.
Oh, we'll come.
where he showed us his periodic table comforter.
And I tend to sleep here right under tungsten.
But the cool part was when he took us to the living room, where he had this,
It looks like an altar.
it's like a little dictionary stand on top of which was a beautiful mahogany box
A fine wooden box
about the size of a backgammon set.
called Periodic Table of the Elements.
It is a very fine wooden box.
And if you care to open it,
Right. It's made of some sort of fine wood.
It comes from Russia.
It does. All right. And is there a trick to opening this? Ooh. Okay, we've all seen the periodic table, on a chart, but in Oliver's box, there were the actual elements. These are all these. We have here like 90 some odd little tubes,
little samples,
little teeny vials
of almost all the elements: silver, arsenic, bismuth, cobalt, oxygen, copper, hydrogen, phosphorus, iron, manganese, mercury, nitrogen, molybdenum, gold. Since I'm, for example, having my 72nd birthday tomorrow, and element 72 is hafnium, there is a little hafnium.
2 little rocks. Here's what they sound like if you rattle them.
I have coming to me, I hope it arrives today, an ingot of hafnium, which would be very much more satisfying.
What would you do with an ingot that you can't do with the 2 little pebbles?
I'll be able to hold it in my hand. My first love of chemistry had to do with the sensuous. Here, one of the liquid elements, bromine. I loved the colours, the brown,
faintly brown, fluidy thing.
The luster, pale golden mercury. Very, very beautiful. The physical properties.
This is a gas trapped in a little vial?
Yes. One wouldn't want to drop that.
Why not?
Well, it's not good to breathe.
Can I just jump in here for a second?
Sure.
But the thing that's really crazy about that box, and this you don't get from looking at a periodic chart on a wall, is that all those elements,
lithium, beryllium, boron, carbon, nitrogen,
that's like the world. I mean, everything that we can see and perceive, this table right here, the teeth in my mouth, the sky, the ocean, the mountains, it's all made of some combination of elements from that box. And the box itself gives it all a deep, deep order.
I had noticed myself, and can't help noticing, that the elements are organized in a very special sort of way. For example...
Excuse me, I have managed to not notice. I find it a little odd that you could organize them at all. I don't even know how to begin the process of figuring out they're related in some way.
Well, then you are sort of recapitulating what everyone felt in the early days.
Of course, in the really early days, people thought there were just 4 elements.
The ancient notion of elements took the form of earth, air, fire, and water. Basically, the thought that the whole world could be composed of these 4 ingredients in different ways.
But then, in the 18th century, we're skipping ahead a bit, chemists began to break things down into these smaller pieces, like wind became
gases, like oxygen and hydrogen and nitrogen.
And earth got divided up into things like
sulfur, phosphorus, iron.
By the way, in order to do this kind of investigating, do you have to boil and pull and tug and fry and steam and do things like that?
All of the above.
So to fast forward, after enough of this boiling and tugging and frying and steaming, chemists got all the way down to the root, which was the atom. That's really what an element is. It's a particular kind of atom. The problem was, though, when chemists began to start measuring these atoms, they found that they were all different sizes and types. Like one would be heavy, another would be light. Third one would be really friendly, likes to link up with other atoms, whereas the fourth would be a loner. And they would come in combinations like heavy, friendly, heavy, shy, light, friendly, light, shy. What was the pattern? That was the question. Could they fit all of these differences and similarities into one big schema?
You mentioned his name. Let me here show you a picture of the...
Here's where we get to Oliver's hero.
The Siberian bigamist, as he is called.
That would be Dmitri Mendeleev.
The great Mendeleev, whom we will talk about.
Oliver has a black and white picture of him on his kitchen cabinet. This man is not going to win any beauty contest.
No, he looks like a mixture between Rasputin and... who do I mean?
Well, you mean he has a big nose, a shaggy, slightly unkempt white beard, a mustache that goes all over the place, piercing eyes, thick eyebrows, and looks like he's in a hunchback position. Generally, if you met him on the sidewalk, you'd probably want to walk around him.
Right. Yeah, he didn't believe in wasting time going to a barber.
Let me just ask you, as to the degree of your passion, when you look at this man, do you think he's a beautiful-looking guy, or do you see what I see?
I think Mendeleev had a beautiful mind. Okay, in 1860, around 1860, there were trains going all over Russia, and Mendeleev could afford to take trains. He was often on enormous journeys, and to while away the time, since he couldn't do chemical experiments or whatever, he would take playing cards with the name of various elements, their chemical and physical properties, and he would play what he called chemical solitaire.
Sorting them for likeness or sorting
Well, I'm afraid I don't know the details.
But you know what we can imagine, right?
Sure.
So let's just say he's sitting there on the train, he's looking out the window, he sees trees made of carbon, a lake made of hydrogen and oxygen. Behind that, a mountain.
Mountains, yeah.
Made of silica. And he's shuffling.
Their properties and their atomic weights in his mind.
Wondering,
How do these things go together?
what's the pattern? And he's shuffling.
I'm shuffling.
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 And he did this for years. Until one night. This we think is true.
In February of 1869, he is said to have had a dream.
In his dream, all the atoms of all the elements of all the world, the fat ones, the small ones, the dense ones, the heavy ones, the friendly ones, the shy ones, they all began to dance in his mind, and then they snapped into a grid.
He awoke with a vision of the periodic table,
This is one of those dreams.
which he then wrote on the back of an envelope.
The thing about what he wrote on the back of that envelope is that it starts out so simply. Left to right, the atoms just get heavier and heavier and heavier.
Heavier.
But every so often, and this is what he intuited in his dream, is that while they're getting heavier, there are other traits, like whether they're shy or magnetic or whatever, those traits repeat.
Periodically change back again.
And every time they do, start a new row.
The properties repeat again.
Out of this simple repeating structure, hush, Mendeleev, you get a table that you can read in a million ways. There are so many ways to read this table
I think I'm going to call this the periodic table.
that if you use your imagination, you can see yourself in there.
I was a rather shy kid with difficulty forming relationships, and I sometimes compared myself to the inert gases.
Inert gases are very isolated. They react with nothing.
Because I felt they too had difficulties forming relationships. But I did...
He has now left the chair and has moved to the library and is taking out a hugely thick, actually a dangerously thick book.
This is the Handbook of Physics and Chemistry. As you see, it has 5,000 pages. I had a smaller version as a boy, and from brooding in this book, it seemed to me just possible that one of the inert gases, xenon, might be seduced into combination by the most active element of all, which was fluorine.
This lonely, lonely gas might find a partner somehow.
Yeah.
Did they ever get together?
In fact, it came to me with great joy when I found out in the 1960s that actually a Canadian chemist had in fact made a fluoride of xenon.
Yes. Elemental love. And speaking of love, he then took
I
us...
think let's come here one sec.